Alex, can you read the first objective?
Describe and define the parts of the URL.
Matt G, can you read the second objective?
Describe how URLs are resolved in a browser, taking missing pieces from the current URL.
Awesome. And Andrew A, can you read the last one?
Describe how linking to style sheets /images/scripts works as far as requests and responses.
Wonderful. So this first part, URL. So URL stands for Uniform Resource Locator. And the idea is, given any URL, one computer can find some other computer on the internet, just given the URL. So think to yourselves for a second, what is one URL that you know of? Adam.
Facebook.com.
So https://facebook.com. Wonderful. What are some other URLs that you know of? Austin? What's that? Is that the, let's find it. Yeah, I did that in college. So. Okay, so they are not HTTPS, but stumbleupon.com. Cool. What are some other URLs that you know of?
Reddit.
But let's do this to make it a little more interesting. Yeah, what do you got? What's your favorite subreddit?
Ask historians.
Trebuchets? Is that how you spell it? Yeah, how do you spell trebuchet? Trebuchet.
It's trebuchets. There's a subreddit
Ships.
called trebuchets.
Like that? Yeah. Nope. Trebuchet memes? This one. Here it is. Okay. But yes, this is a website. Well, but this is also a URL. Let's also do this. What about when I go to Amazon.com and you see all of my browsing habits, but I search for something like, what should I search for?
Did you just want us to so that we buy you new
No.
phone?
Xylophone. Is that how you spell that? No, xylophone's with an X. Jeez. Either way, we're going to take that URL, and that's another URL. But the idea is any website on the internet is going to have some sort of URL that's going to allow you to get to it, right? So this URL is made up of various parts. And any URL, and actually let me just, I'll leave it there. Any URL is going to be made up of these parts so that way when a request is being made to a server, it can know where to find it. So these are some examples of URLs. Let's go into my slides. The first one I have here are what are the parts of a URL. So if we look at this example URL, it's broken up into different sections. The first section is the protocol or schema, which describes the protocol of the thing being requested. So in our case, the protocol is most always going to be HTTP or HTTPS. So Hypertext Transfer Protocol or Hypertext Transfer Protocol Secure. But the URL begins with the name of the protocol, //. We then have the host or the domain. So where is that server located? Yesterday I didn't talk about the details of like how we figure out where a domain actually is. But let's just gloss over that again and let's say the URL has a domain. Your computer can find where that domain is. Next, it has a port. Now, in the world of the web, port 80 is the default port. So for all of these websites that we visited, you'll notice there is no port listed. That just means when your browser makes that request, it's automatically making the request either to port 80 if it's HTTPS or port 443 if it's HTTPS. But you technically could throw that port on there and it'll still work. So let's do Amazon.com on port 80. Go. Well, it needs to be 443 because it's HTTPS. And it just like disappears because their server kicks in. But that's being hidden from you. The port is usually always there. And you could have a server that doesn't use 80 or 443, and then you just specify the port that's on there. Often when I'm using locally hosted slides, I have it running on port 1337. But in the URL, you just see :1337. So okay, we've got the protocol, we've got the domain, we've got the port. The next thing in blue is the path. So this is where on the server are we requesting the thing. In this case, it's in a folder called A, which is another folder called good, which inside of it has a file called path.html. So this is what you're actually requesting on that server, on that port, given that protocol. The next thing is the query string. So this is often used for like changing up the results. So like if you like enter in a search term or something like that, instead of the rest of the URL changing, just the query changes. So like search equals search term, and that can be like dynamic. But it's essentially key value pairs separated by ampersands, and the key is on the left, separated by an equal sign, and the value is on the right. We'll see some more examples of that. And then the last part is the fragment. So you might see on some websites, so let's go to like Wikipedia. What Wikipedia article should I search for?
Trebuchets.
Turtles. Okay, so this is the Wikipedia page for turtles, but you'll notice if you click on the table of contents, watch what happens to the URL. Fragment behavior. And if we actually look at the source of this page, this right here has an ID of behavior. So it actually allows you to link to a specific section on the page itself. So any one of these other links, in captivity. Ooh, cool. Skin and molting. But that part of the URL actually doesn't get sent to the server. It's just describing where on the page should the browser load that page. And those are all of the parts. Let's look at the examples that we came up with and kind of like, let's see if we can break it down. So let me just like zoom out. It's a whole lot. Okay. Everyone think about it for 10 seconds. Can anyone see that? Oh, I'll zoom in. Okay. Everyone think about it for 10 seconds. Which part of this URL is the path? Think about it for 10 seconds. All right, I'm going to cold call Steven. Which part of this URL is the path?
After .com the slash all the way up to the letters, like C/ref.
There, yeah, totally. So the idea is that is describing where on the server we are requesting something. It might actually be, this might be included in the path. We can't really tell. Usually the next part of the URL. So let's say, let's break it out. Let's say that the path is that. Okay, think about it for 10 seconds. Which part of this URL is the host or the domain? Right, I'm going to cold call Michael. Which part is the domain?
Amazon.com.
Yeah, and you want to include www. So www.amazon.com, that is the domain. All right, got a few things left. Which part of this is the fragment? Think about it for 10 seconds. I'm going to cold call Ross. Which part of this URL left over is the fragment?
Zalva?
It's a bit more than that.
I guess the keywords equals out.
So I actually didn't clarify. It's literally everything that comes after the question mark. So yeah, in this example is like a very simple example, but let's say foo and bar and name equals Ross and thing equals what. Everything after the question mark is the query string. So basically all of that is the query string. And I think I said fragment, didn't I?
Yeah.
There is no fragment. None. The query is that. Okay, on 3, everyone say what the protocol is. 1, 2, 3. So the protocol left over is HTTP. I mean, I said it so quick because it's like literally the only thing left. But this is the protocol. So any URL on the interwebs can be broken down into these parts. Like, what's the protocol? What's the domain? What's the path? What's the query string? What's the fragment? So I want everyone to take 5 minutes, visit all the websites that you visit on a normal, everyday basis. Well, not all of them. Anything that's classroom appropriate, and just create a document and just put the URLs in there. We're gonna try to break them down. Sean.
Can you go back to the screen that has?
Oh, absolutely. Yeah, the parts. So visit websites like go to Reddit, go to Amazon, go to Apple, YouTube, anything, and just find those URLs. We're gonna break them up.
Galvanize learn, galvanize mastery, code wars. That's it. Is it boldface or baldface? Boldface.
Bullface.
It's a bowl cut.
That's a bogus lie.
Actually, let's throw those URLs in Slack. Let's kind of like break them down. So any URLs you find, just Slack them out. All right, I think that's enough time. Has everyone slacked out any URLs that you found? Let's check them out. Ooh, this is a big one. Okay. So, for the worthy prize of a sticker, who can break down this URL for me and tell me all the parts? Adam, you want to try?
The HTTPS is the protocol.
Protocol.
www.facebook.com is the domain.
Domain.
Events and all those numbers that follow it. I'm not even going to bother saying it. Is the path.
Mm-hmm.
Everything from the question mark on through is the query string, and there is no fragment.
Wonderful. Give him a hand. Okay, I've got a. Yeah, Kyle's back there. I've got a JS sticker. Some emojis. All right. Let's look through those URLs real quick. Anything that looks confusing? Anything you can't really find the protocol on, or?
Can you show us a real world example of a fragment?
Yeah, definitely. Well, I mean, Wikipedia was the example where when you click in the thingy, the thing. Yeah, so you can't really see it here, but notice how the like when I click on something in the table of contents, the URL changes, and then the fragment is actually the section that the document's going to go to. I'm talking to you, Matt. You're not even looking at me.
Oh, sorry, he's talking.
Cool, that's okay. But like when I click on something in the table of contents, the thing actually changes.
I see.
This is one way of using it. We're going to be using it in front-end frameworks where it's a single-page application. Like the page never actually changes, but the fragment changes, and then JavaScript kicks in and like changes the page based on the fragment. It's cool stuff. Marlena.
Oh, okay, so that's probably answering my question.
Sure.
I grabbed the link, the URL for Gmail.
Oh, yeah, that is a single-page application for sure.
The fragment inbox.
Exactly. So that's the inbox tab. What happens when I click on starred? Yep, and then it changes to starred, and then sent, and then drafts. So JavaScript is kind of like hijacking when the fragment changes, and then like literally injecting a new page, like, and because you'll notice there's no refresh, right? It's literally, this is Ajax, which we're going to learn about today, happening behind the scenes, making those requests and swapping it out. Yeah, it's a really good example. So yeah, inbox, and then starred. Cool. Any other weird looking URLs or anything like that? Yeah, and so like one thing to kind of talk about is that query string can have a lot of stuff on it. But one thing to note is like on Amazon, this query string, like if I shared this URL with somebody, Amazon would know that I was the person that shared this URL. Because this quid ID and then like these other things, that's like unique to me. So the moment somebody else clicks that link, they're like, oh, those two people know each other, and they're like sharing links. So stuff like that can happen.
Would they be able to get, like, they couldn't like get on your account and order stuff?
Oh, no. Yeah, like this is literally just a link to the product page, but the information could actually be used by Amazon's server to say, okay, the person that created that link was this user, the person that clicked on it was this user, they know each other somehow.
That's true. What if you're like not logged in? You guys still track like what?
They might have, they probably definitely set a cookie in your browser, so even if you're not logged in, they still know, okay, this user who was not logged in but looked at all these products is now sharing that URL. Yeah.
What if we don't set cookies on them?
Then they couldn't do that. But yeah, you can have like a browser extension, or you can change the settings in Chrome to not accept cookies. But a lot of sites will break if you stop accepting cookies. Like they depend on it. That's really it. Those are the parts of the URL. The next thing I want to talk about is, actually, let's say this. What is the port for this URL? Everyone think about it for 10 seconds. Kind of mentioned it earlier. All right, who thinks they have an answer? What is the port for this URL? Will.
80.
Is it? Look at the protocol.
Is it? So I forget. Is it 402? What is it?
443, yeah. Yeah, and this is just something you have to commit to memory. So HTTP, the default port is 80, and HTTPS, the default port is 443. And that's because when your browser makes the request, it takes into account the protocol and automatically puts that port on there. Will.
If you use like 3,000 or something, like for like a local server,
Yeah.
Is that a specific number, or is it just like anything other than 80 and 443?
It's when the servers that we run locally, they default to port 3000, but it's literally just a number. You can pick any number from 3000 on up. There's a maximum limit, but what that number is it's a port on your machine. So every machine has many different ports that can be opened, and by opening that port, you're allowing traffic in. So their servers have an open port on 80. When we start up a server, it opens up a port on 3000, but you could tell it to open up a different numbered port.
Why do we have to commit that to memory?
Just because it's a one of us kind of thing. Like,
Okay.
yeah,
Like we use it.
yeah.
You can't like infer it from, like it's not written there.
Right, that's what I was like, why would I?
And that's why, because you're not going to see it in the URL, but you should know HTTPS defaults to 443. Yeah, you're in the club.
Well, if you ever end up setting up like a network or something like that, and you're like, why isn't web traffic coming through, but everything else is working fine? Port 80 is probably the thing you want to check.
Yeah.
I remember in school when they started to like block sites, you could put HTTPS instead of HTTP.
Oh, yeah, because they were blocking that specific port. And so the moment you do HTTPS, like the school, like their firewall isn't.
And yeah, then they called you like a hacker or something because your IT manager was too stupid to block both ports.
Yes. Okay, describe how URLs are resolved in the browser. Actually, I'm going to skip that one, and we'll do this last one. Describe how linking to style sheets, images, and scripts works as far as requests and responses. Kyle, can I use that whiteboard? Or?
Yes, go ahead.
So yesterday we talked about the request response cycle. So I'm going to draw it here with a client and a server. And yesterday the thing was like highly annotated, but a lot of times this can just be drawn very simply. So let's say I'm requesting the home page of a server. So I'm making a request, so the arrow goes from the client to the server. I'm making a GET request for /index.html. Has a version, HTTP 1.1. There are no headers, there are no bodies, so we represent the request like that. Now the server is going to respond. I think this is the same marker. Is this the same marker? Oh, no, that's nice. The server is going to respond with the contents of the document that was being requested. So if this is a successful response, what is the status code? 200. And then we'll say HTTP 1.1. We'll say there are no headers. What would the body of this request be? Think about it for 10 seconds. What's the body of this request? Right, I'm going to cold call. Matthew Victor, what is the body of this request?
Index.html.
It's literally the file itself. Yeah, so if we talk about the body here, which is the third part, it's literally the HTML that is contained within that file. So we've got HTML there. Let's say we have a head. And then we have a link. Is link SRC or href? Style.css. It's missing some other things, but that's okay. And then let's say we have a script. SRC equals app.js. We can close off the head. We have our body. It just has an h1 that says hello. Close our body. Close our HTML. This is the body of the request that's coming back to the client. So when the browser gets this body, it parses it and turns it into the DOM. So parse HTML, create DOM. So I use this term parse. You're going to see this all over in programming and computer world. It's literally a word for the computer is literally looking at all of the characters in this string and deciding what to do with it. It's parsing it. It's looking through it. So in this case, it parses this, turns it into the document object model. Now, when this thing has been parsed, there are two things that the browser now needs to request also. There's this and this, right? Because this one request is only going to give us back the contents of the HTML. If we want the styles and we want the JavaScript, the browser needs to make subsequent requests. So it parses this thing, it comes across this link and says, oh, I need to make a request for style.css. So the browser then makes a request. What should the method be? I'm trying to grab that file. What's the method? Get. Just like index.html, we're going to be getting style.css. So the path in this case is style.css. This kind of falls in line with that other objective that how does it resolve the URL? Because this document was loaded at /, it automatically is going to request this from /. It's like a relative URL. So it gets style.css. We throw the version in there. This thing will then respond with, what's the status code? If it's there, if it exists. 200. Oh, A-okay. And everyone think about this for 10 seconds. What is the body of this response? What is it going to be? What's it going to look like? Andrew A., any ideas?
Should just be HTTP all the way through, right?
Well, yeah, but what is the body of this request was the actual HTML file. What will be the body of this request? So we're requesting style.css, so it's actually literally just going to be this file that we're requesting. So we're going to get, let's say this has like a body style, like font family. Like that. And the idea is this response, like this is the thing that we're requesting, right? So in this case, we're requesting the whole document. In this case, we're requesting that one specific file. So we're just getting the contents of that file. So then the browser will take the CSS, parse the CSS, add the styles to the document. Now, based on what I've shown you here, can I have a volunteer to draw what happens next and why? Will? So what happens next and why?
All right. So the client is gonna make a request to get the app.js script because it's the next thing down that it's gonna look for that it needs. Wants it in the same HTTP 1.1, and then the server is going to respond with, if it's there, 200 format you want it in.
You can define what's in it.
I'm sorry.
You can describe, like you can come up with what the body is. What is the body?
Okay, the body's gonna be the text content of the JS file, so whatever that looks like, it's gonna be probably a document ready function if it's jQuery and
Let's say there's a console log in there.
Okay.
Yeah.
So it's gonna be like jerk.
Literally just a console log. Like literally.
Whatever.
Yep. We get an undefined reference, but that doesn't matter because it's just text at this point. And then
It's gonna parse the JS file
and run the code.
Yeah.
Yeah, cool. Give him a hand. Cool. So this is why we were talking about requests and responses yesterday. Like literally everything in the browser is requests and responses. So the first request gets the document itself. It then figures out, okay, I need to make subsequent requests. If there was an image tag in here, it would have to make another request for that image tag. And then the other thing to kind of like really drive home is like the body is literally just the text content of the thing that we're requesting. So when you're requesting an image, it's actually like kind of like binary data, but the body is literally text that represents the image that you're requesting. So the text of the CSS file is just literally CSS text. The text of the JavaScript file is just literally the JavaScript. And I made that joke, like when this code comes over, like it doesn't matter if there's an undefined reference, it's just getting the JavaScript. And then when the engine starts to run it, that's when you'll like get errors and stuff like that. But it's really important to think about this when you're building your apps. Like where are you bringing in script tags and style tags? Where are you bringing in image tags? All of these requests have to be made. We're about to start talking about AJAX requests, which allows JavaScript to make requests without refreshing the page. So you could just be, your page is sitting there and then JavaScript will make the requests out to get some data or something like that. Questions or comments on this request response diagram? Will?
This is like kind of a trap, but like, I was just looking at the difference between a URI and a URL for like magnet links for torrents, but does that process look, I imagine it looks different since it's...
If it's HTTP, it's going to be doing this. If it's a different protocol, it's going to be looking like something else. This request response diagram is specifically for hypertext transfer protocol. Yeah. I want everyone to just stare at this for like a good 10 seconds. Can everyone see it? Mostly. Now I want you to describe to someone at your table what is happening here and why. Okay, you're going to be describing this diagram. Make it happen.